Today we're going to be doing 9 times table and division facts. How many hearts are there in total? Complete the multiplication fact. Now, of course, we're doing the 9 times table, so each card has 9 on it. What is the equation we have to do? What do we have to fill in here? 9 times 4, right? 9 times 4, and what does that give us? 36, good. Okay, so we did some ways of working out the 9 times table. You can also do 4 times 10, and then you just have 40, and then you just subtract 4, okay, to get your answer. Right, let's move on. Colour in the multiples of 9. So basically the 9 times table. Right, I'm going to use my highlighter. What do I colour in first? 9, okay. Next. 18, starting to see a pattern. Next. 27, do you see the pattern? 36, it's a diagonal. 45, good. 63, 72, 81, and then what? 90, and after that, 99. Yeah, the table doesn't go up to 108, so we'll just leave it there. And it says, what pattern did you notice? Well, it goes in a diagonal, and then here is the other diagonal. If you had more of the table down here, then you'd probably find 108 would go here. Okay, and it would continue this way. Right. What is 72 divided by 9? Now we should use the table here. Okay, the answer is 8. Let's see how many down it is. So we've got 1, 2, 3, 4, 5, 6, 7, 8. Yeah, that's how we can check. So 8 times 9 is 72. Right. So we put 8 here. What about 27? Oh, the other way we can do is counting backward. 3, right? 1, 2, 3. Okay, because if you count backwards from the coloured number, you'll find the answer. Complete the calculation. So this is testing your 9 times table. 3 times 9? 27. Here we need to go backwards. So what we're doing is 12 times 9. No, 12 times 9. Good, 108. That's because we were doing it a lot last lesson. But if you're not sure, you can always do 10 times 9 equals 90. And then 2 times 9 equals 18. And then you can do 90 plus 18 to give you 108. And remember, when you're going backwards, you have to times to get this answer. Okay, C, 9 times 4. 36. Yeah, it's just another one onto 27. Again, here we have to go backwards, so we have to do 1 times 9 equals 1. Yes, so 9 divided by 9 equals 1. Good. 11 times 9, 99, nice easy one. Okay, 10 times 9, also easy, 90. Okay, 6 times 9, 54, good. Okay, so now for this one, again you need to go backwards. 18 divided by 9 will give you this answer, 2. Yeah, you can also see 9 times 2 is 18. 9 times what is 72? 8, good. Okay. What do you divide by 9 to get 11? So again, you can do 11 times 9. What does that give you? 99. So 99 divided by 9 gives you 11. Okay, 45 divided by 9. 5. Okay. 20 times 9. Okay, good. Yeah, because 2 times 9 is 18. But 20 has a 0, so there we go. Complete the number tracks. So again, your times table. What comes after 18? 3 times 9, 27. Here. 36. Here. 45. 54 is done for you. What's after 54? 63. 63. Yeah? 9 times 7, that is. Okay. Now this one, we're going backwards from 108. So we're minusing 9 each time. 108 minus 9 is 99. Yeah, so the next one must be 90. What goes here? 81. And then it's 72. What goes below 72? 63. Okay, see, we're here now. So what must go here? 54. Yeah, in this one we're adding 9, and in this one we're subtracting. These numbers are all multiples of 9. Okay, so we have 45, 54, 18, 108. How many times does 9 go into 45? 5, good. How many times does 9 go into 54? Good. How many times does 9 go into 18? Yeah. And how many times does 9 go into 108? 12. Yeah, we've done this so often that we just remember now. Another way of checking is the 4, you just add 1 to the tens. 5, 6, 1, 2. A, show that the sum of the digits of each number is the same. Show that the sum of the digits of each number is the same. Now, what does sum mean? What do you have to do if it's asked for the sum? What does sum mean? Add. Now, what they mean by digits is they mean these two numbers. So we have 45, so that means 4 plus 5 equals what? Yeah, 9, okay? Now, 54 means if they want you to do the sum of the digits, they want you to add each number together. 5 plus 4, what does that equal? Okay, now we have 1 and 8, or 18. So we have to add these two numbers. What do we get? 9. Now, the way you do this one is this is not 10 because they ask each digit, which means each individual number. So in other words, you have to add 1 plus 0 plus 8. And what do you get? 9. So this little pattern works, doesn't it? Works for the 9 times table. It's just an interesting pattern. Oops. These numbers are also multiples of 9. Let's see if it still works, even though these are very big numbers. What is the sum of the digits of each number? So we have 198. So this time we have to add 1 plus 9 plus 8. Yeah, doesn't work now, does it? 18. Let's see. I think these numbers are too big. 657. So 6 plus 5 plus 7. What do we get? Also 18. 8 plus 9 plus 1. What do we get? 18 again. Now I have a feeling this is not going to work, is it? 9, because you know your 3 times 9 is 27. So you see interesting patterns here. At some point, you always get 9. And then maybe in the hundreds, you start getting 18. And then as you near 1,000, you start getting 27 when you add all the digits. So there is some kind of a pattern, but it's not always the same, so it changes. Okay. So this girl is saying, I've noticed something about the sum of the digits of numbers that are multiples of 9. What do you think Whitney has noticed? So I think that's going on from the previous question here. What did you notice about the results? So we got 9 here, we got 18 here, and we got 27 here. What do you notice about those results? Is there something special? Okay, well, they're all multiples of 9, aren't they? They're all in the 9 times table. So if you add all the numbers that make up a multiple of 9, you get a number which is in the 9 times table. Here you get 9, here you get 18, and here you get 27. Okay. So here it says 7. So this must be 7,590 something is a multiple of 9. What is the missing digit? Now, we know that if we add all these numbers, we should get something that's in the 9 times table. Let's start adding. So we've got 7 plus 5 plus 9. What do we get? They're the numbers we have got. We don't know what this number is. We're going to work it out. So what's 7 plus 5 plus 9? Well, I'll show you an easy way of doing it. 9, if you want to make it into an easier number to add, you just change it to 10 and take away from this one 1 to make it 4. So 4 plus 10 equals 14. So then 14 plus 7 equals 7 times table. 3 times 7 is 21. Yeah, good. Now, 21 is not in the 9 times table. What number is in the 9 times table, which is close to 21? 27, good. Yeah, I suppose 18 is closer, but we need a bigger number, yeah? So we got 9, 18, 27. 27 is, we need a number which is bigger, but close to 21. So it's 27. Now, what is the difference between 27 and 21? In other words, 27, take away 21. What does that equal? Okay, so let's try and get to 27 from 21 by counting on our hands. So we got 22, 23, 24, 25, 26, 27. Okay, which means it's 6. I counted up 6. Okay, so this equals 6. Right, so the missing number must be 6. Let's just check. So 7 plus 5 plus 9 plus 6. Okay. Now, we can combine 5 and 6 to make 11. So that makes 11. And then if you want to make it into a 10, you could put the 1 here. So let me make it simple. 5 plus 6 is 11. Plus 9 plus 7 is 16, yeah? So now you have to do 11 plus 16. And that will give you 6 plus 1 is 7 for the ones, and 1 plus 1 is 2. Okay, so you get 27, which is good, because that is a multiple of 9. That is in the 9 times table. So we are correct. That means the missing number must be 6. Does anyone have any questions about that task? Because it is a bit trickier than some of the other tasks. Does that make sense? If there's any problems, let me know. I can go over it again if need be. Okay, let's move on to this one. Jack is making arrays. They always use the word arrays for when they're putting counters out. And so there's a row of 4 going this way. 1, 2, 3, 4. And then going this way, let's see, 1, 2, 3, 4, 5, 6, 7, 8. This is 9, and this would be 10. Use the arrays to complete the multiplications. Okay, well, 1 times 10. So 1 times 10, I'll try and do a straight line. There, 1 times 10, what do we get? How many counters are there? Well, it must be 10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's one row of 10. Okay, moving on. Now they ask for 2 times 10. Okay, so that would be all these counters together. Does anybody know what 2 times 10 is? Well, let's count. 1. Yeah, it's 20. Nice and easy, that one. Okay, you could count them all, but I think you know that one. Now, they're demonstrating here how, if you know the 10 times table, you can work out the 9 times table. So we did 1 times 10 was 10. What's 1 times 9? 9, yeah. Okay, so we skipped the yellow one. 2 times 9 is, well, we have 18, right? Yeah. We have 20, and you just need to take away these 2, right? To get 18. Because we know 2 times 10 is 20, 2 times 9 is 18. Okay. Now we get onto the more difficult ones, right? Okay. I say more difficult, I'm sure you can do them. 3 times 10 is what? 3 times 10? 30. Right, yeah. It is 30. Now, 3 times 9? 27. Okay, and again we can see this. So we get 30 from 3 times 10. Then we need to subtract 3. These 3 yellow counters. Now, 4 times 10? 40. So what is 4 times 9? 36. Okay. Now here again you can see all you need to do is subtract 4 from 40. 4 yellow counters away from 40. Okay. So now here, write steps for a partner to explain how you can use the 10 times table to multiply by 9. Okay, so what can we write first? So you're helping a friend to know the 9 times table through the 10 times table. So what we just did. Okay, so let's look at an example. Let's do a higher one. Okay, so we did 4 times 10. What did we get? 40. What did we do to get 36 from 40? How did we get this? So we got the 40, but we need to get to 36. How do we get to the 36? What do we do? Yes, subtract 4. So you're subtracting the same number that you're multiplying by, right? Again, so here, 3 times 10 is 30. What do you subtract to get 27? You subtract 3. 30 take away 3 equals 27. Yeah, 30 take away 3 equals 27, or 3 times 9. 40 take away 4 equals 36. So here, 20 take away 2 equals 18. Here, 10 take away 1 equals 9. Okay? So you need to explain that here in an equation. So let's have a little look. Let's do 5, because we haven't done 5. 5 times 10 equals what? 50. Okay, what do we have to take from 50 to get the 9 times table? 5. Good. And then we get 45. And so the 9 times table is 5 times 9 equals 45. Okay, now, do you remember, some of you might not, but we've used shapes to represent numbers, okay? So we'll use the triangle to represent the number we're timesing by 10. And that will look like this. So we use the triangle, and we times that by 10, and then we get a triangle in the tens, and 0, that's not a circle by the way, it's a 0, in the ones. Okay, so triangle and 0, take away triangle, remember this is representing the 5, will give us, well we don't know, but it will give us the same as this, 5 times 9. So it will give us the same as triangle times 9. Okay, now that might not make sense. So let's swap the triangle for a number. Give me any number between 8. Okay, let's try 8. Somebody said 8. So I'm going to rub out all these triangles, and instead of triangles, we're going to have 8. I'll do it in a different color. 8 times 10 equals 80. 80, take 8, equals 8 times 9. Yeah? Let's try another one. Who can give me another number? It doesn't matter what number. As long as I don't think it will work above 9. Let's try a number below 10. Give me another number, any number. 6. Okay, 6 times 10 equals 60. 60 minus 6 equals 6 times 9. Okay, so let's do what I said might not work. And use a larger number. So let's use a large... Give me... I'll try it with 11, because I don't want the number to be too hard. What is... Okay, whoops, I want to use yellow. So we know that's yellow. So 11 times 11, what does that give us? 110, so far it sort of works. 110 take 11. What does 110 take 11 give us? What does 110 minus 11 give us? Okay, well, 11 is 10 plus 1, isn't it? So you've got the 10 here, so why don't you just take the 10? So then you're left with 100, but then you need to take another 1, because you've got one. 99, right. And that's correct then, isn't it? 11 times 9 is 99, so it did work. Let's try 12. So we're testing out, this is called a formula. So let's just see if I can just do this. Oh, and then that. I'm going to change it to 12. I don't know if this will work, but we'll see. Gives us 12 times 10 equals 120. 120 take 12 equals 12 times 9. So what does 120 take 12? Not quite. So let me help you a bit. So we've got a 10, 1 10 and 2 1s. So let's take the 10. So 120 take 10. What does that give us? Remember, we have to take, here are the 10s. So you've got 2 10s here. Take away 1 10. What does that give us? Okay, I'll tell you. It gives you 110. And then you've got 2 left. So you need to do 110 take 2. What does that give you? 100. So what's 10 take away 2? Right, good, 108. Yeah, so that's correct, isn't it? 12 times 9 does equal 108, so that works as well. Okay, so this is our little formula. Yeah, we can whenever we use a shape, we can put any number we want in it. Okay, so we chose the triangle, so we can put any number we like in this equation and get the answer. And this is how we're demonstrating how to use the 10 times table to get 9. It asks us to work out these multiplications. Okay, so it's saying 19. Ooh, that might be a little bit tricky, but let's see. So instead of triangle, I have to rub these triangles out again. And instead of the triangles, I have to put 19 in. Let's see. 19 times 10 equals 190, right? So 190, I should have done it a different color, sorry, it should be yellow, never mind. 190 take 19, what does that give you? Now the easy way to do this is 190 take 20, what does that give you? So it gives you 170, yeah, because you're taking 2 tens from 9 tens, gives you 170. So 170, then you need to take another, then you need to add 1 because you've taken too much. So you need to add 1, sorry, equals 171. Okay. Yeah. So this and this, then we have 19 here. Right. Now,